All right, so Newton's third law of motion is an action and reaction law. Basically what it says is for every action, there is an equal and opposite reaction. So like on the teeter-totter, if you push down on one side of the teeter-totter, the reaction is the other side will move down and it will be at the same force, the same rate. So forces are always equal in magnitude, but act in opposite directions in an action and reaction. So Newton's third law, again, have equal forces, action and reaction forces that are in opposite directions. So if an object A exerts a force on object B, then object B exerts a force of equal in strength in the opposite direction of object A. So when we express this, the force of AB will equal negative force of BA. This negative in this case just means in the opposite direction. So the law of action and reaction says in every interaction, forces occur in pairs. Action and reaction, these two forces act in opposite directions with equal magnitude. So for example, in the rocket propulsion, you need to show these arrows and show the action and reaction in your notes. In a rocket engine, burning fuel produces hot gases. The rocket engine exerts a force on these gases, causing them to eject downward. As a reaction, Newton's third law, the gases exert a force on the rocket, pushing it upwards. So we have an action of the gases pushing down, and the reaction is the pushing upwards of the rocket. Kicking a ball. The ball gets kicked forward. The reaction, the foot decelerates by the ball in the opposite direction. So again, make sure you are showing these arrows and explaining what is going on in these action and reaction pairs. The food on the table. The food is pushing down on the table is pushing up on the food. Therefore, the food is not moving. So action, reaction. These action and reaction forces don't cancel. According to the third law of motion, action and reaction forces act on different objects. So going back to this example, the first force pushing down is the food on the table. The opposite force is the table pushing up. So thus, even though the forces are equal, they are not balanced because they act on different objects. All right, so your turn. If you were wearing roller skates and pushed against a wall, what would happen? Go ahead and draw a diagram. You can use stick figures in your diagram. But what you need to show is that a person is pushing against a wall. And the force is pushing one way while the motion is going the opposite direction. So again, a person pushes in one direction against the wall, causing motion in the opposite direction. True or false? When a bug hits a car windshield, it splats against the force of the car, and the bug is greater than the force of the bug hitting the car. False. The forces are equal, but the bug's tiny mass results in a huge deceleration. Newton's third law of motion leads to the law of conservation of momentum. A moving object has momentum. It's where the oomph or the strength of a moving object comes from. It is how much force is needed to change its motion. The momentum of an object is the product of its mass times the velocity. You learned that from the car crash video that we watched earlier. Momentum is mass and velocity. When objects collide, the result of the collision depends on the momentum of each object. When the first puck hits the second puck from behind, it gives the second puck momentum in the same direction. If the pucks are speeding towards each other with the same speed, the total momentum would be 0. What might happen if car 1 was stopped and car 2 hit going full speed? How would the momentum and motion of the car be impacted? What would car 1 do? What would car 2 do? And why? Okay, so first draw yourself in the car. that you would rather be in. I really hope you would rather be in car 2. So show this. Off to the side, now explain. During the collision, the force of the cars causes a change in the momentum of the cars. However, the total momentum before is the same as the total momentum after the bumper cars crash. Car 2 would lose momentum and slow down. Car 1 would gain momentum and speed up. The total momentum stays the same, but the momentum just gets transferred from car 2 to car 1. Momentum is given with a symbol P and can be calculated with mass times velocity. So the unit for momentum is kilogram a meter per second. So notice that the momentum has a direction because velocity has direction. So you can use this as a vector quantity to show which direction the momentum is in. So example, calculate the linear momentum of a pickup truck that has a mass of 1,155 kilograms and is traveling eastward at 38 meters per second. Okay, so first off, we have the formula, momentum equals mass times velocity. The mass is 1,155. The velocity is 38. So we plug those in the formula, we get 1,155 times 38, and you get 43,890 kilograms by meter per second. So again, linear momentum is mass times velocity. Now friction. The definition of friction is the force that opposes the sliding motion of two touching surfaces. Factors that can affect friction, types of surfaces, how hard surfaces are pushed together, and know that without friction, a moving object will not move until it strikes another object. So it will continue to go on forever and ever. So looking at this diagram above,